So if you've ever seen a bell curve being used, that's called a normal distribution. And so what I want to do today is to show you how to create that in Excel. Now it's important because statistically speaking, it gives us the most information, and it's one of the most effective ways within statistics to find what you're looking for, and one of the easiest ways as well. So the idea behind a normal distribution is that when you start to look at the population as a whole, and you can look at this in many different areas such as height, age, weight, and in this case I'm going to use 2100 ACT scores, what we tend to see is that most people fall within a range, or what we call a standard deviation, of the middle, the mean, or the average. And then you see some people to the left and some people to the right of that initial area. In other words, the average person tends to fall in the middle. You've got some that are low on the left and some that are high on the right. Now, to be more precise, we can look at this second one here. So 68% of the people fall within one standard deviation of the middle. Now, what a standard deviation is, it's a measure of how spread out numbers are. In other words, if the standard deviation here is 1, then the majority of people fall with either somewhere between this 1 and this -1. So they're average. And then we say 95% of the values are within 2 standard deviations, so here and here. So 95% of the population falls between this number 2 and this negative number 2. And then roughly, and you'll see here this is 5%, the reality is 99.7% are within 3 standard deviations, so here and here. Now the thing you have to understand is a standard deviation can literally be any number. It can be a 1, 2, 3, 4, 5, whatever. It just means that that amount is how far from the middle the majority of people are. So let's move this out of the way and we can actually look at how this looks. So when we move it over here, what we see with this distribution of literally over 2100 ACT scores is that the average is a 19.33, so it's up here. Then we see that the majority of people fall somewhere between 15 and 25, or basically with our standard deviation of 4.67. So from that perspective, the majority of people, 68%, score somewhere between 19.33 minus 4.67 or 19.33 plus 467. So this initial range here in the middle, that's where the majority of ACT scores fall. Then to a lesser extent, we see the 2 standard definitions, which means that scores between basically the 10 here and a 14, this area here, and then over here the 25 to 30. So 95% of the population falls in this range right here, and then 5% falls on this extreme left end or this extreme right. In other words, very, very small amounts of individuals are here or here. Roughly 5% fall somewhere in this area here or here. The overwhelming majority, of course, are right here in the middle. So how do we find this? So what I've got are these ACT scores here. And the first thing we have to do is to figure out the average. So we can do equals average. And to do our range, we're looking at A2 to A2117. So we hit enter, and that gives us a 19.33. So that's our average, that's our mean. So the next thing is to figure out the standard deviation. So I'm going to go over here to formulas and more functions and statistical because I want to point something out. So we have 2 standard deviation formulas here. We have one that's an S and one that's a P. The difference here between the two is that standard dev.P is the entire population, whereas standard.S is a sampling of the population. When I did the calculations for this, I used both just to see, and they came up the same, which tells me that because I'm literally talking about over 2,000 scores, the standard deviation.P is a formula that I could use for this. If I was using, say, 20 or 30 scores, I would definitely want to use S for a sampling because then I'm getting a little more generalized. So choose my formula, and I need to change this to be A2117, which is the same as my average. So then we see here my standard deviation is 4.67. So all of my scores, roughly 68%, are going to fall within one standard deviation of this. 95% will fall within two standard deviations, or 4.67 times 2. So once we have this information, we then generate the normal distribution, which is going to give us the graph. So to do this, we type in NOR and we come up with this norm.dist. So this is the normal distribution formula. Now it needs three things. The first thing it needs is our x variable, which is our first number. The second, it needs two constants. The first is the average. We'll put a dollar sign here because of course that's going to stay the same. It's not going to change as like the variable for x will. And then the next is going to be standard deviation, which will need a dollar sign as well. So we have these three parts to it: A2, B2, C2. So these are the three areas, and then we have this true and false. Now we want to use false here. We want a probability mass function. So that gives us our number. And then we can take this and drag it down and autofill all the way through. And that gives us the normal distribution that we want to use. So the next step is to highlight both of these columns. We're going to go to Insert, and we're going to choose a scatter plot. You'll see here. This gives us the normal distribution. Now, right away, a couple things we want to do. We're going to come over here, and we don't need, from an axis standpoint, we don't need the vertical. All we want is the horizontal because that's the ACT scores. So I'm going to do axis titles, and I want the horizontal. So these are the ACT scores, and here's my normal distribution. And this is, of course, what we saw over here. So that's what we do. We have our scores, and then we just get the mean, which is our average, the standard deviation, and then we use that normal distribution formula to generate the bell curve that we see here. And then that gives us an idea of where our scores are falling. So when we talk about improving scores, really what we're talking about is taking that number and actually making it smaller, reducing the standard deviation, because we know no matter how many times we do this, we're going to have people that are on the left and we have people that are on the right. Our goal, of course, is to reduce the standard deviation so that we end up with more people here in the middle and less people overall to the left, because we know we're going to have people everywhere, but by reducing that, at least we get closer to that average. So that's how you create that normal distribution graph you see here.